Assalamu alaikum everyone. Today we are going to conduct lecture number 9 of this online course, and the topic of today's lecture is stake segment. Stake segment is something that we cannot cover in single lecture, so we have to take multiple lecture on this stake segment. So this is just a starting and basics of stake segment that we are going to learn in this lecture. So let's proceed to our this lecture. Okay, let's start the topic, which is a stake segment, and it is one of the segment, as we have already learned. Memory which is connected to 8086 or 8088 microprocessor is divided into various segments, and one of those segments is the stake segment. Beside this stake segment, we have code segment, data segment, and extra segment available. While I have considered this diagram from a very good lecture on stake, and I have chosen this diagram because it explains a very good fact, which is very important and a very uh, integral difference between the code segment and the stake segment. This blue thing indicates that it's a code, and this red thing is indicates is it's a stake. Okay, and we have only single chip, and since we know that in a single chip we have several segments, so code is storing in the same chip, and similarly stake is also storing in the same chip. The only difference we see here is their sequential flow direction. Code is storing in this way. If you can see, the first byte of code is stored here, and then here, and then here, and then here, and then here, and so that is the direction for the code. While in case of stake segment, first byte stored here and here, and then here, and then here, and then here. So that is the key concept or the key difference. Both are sequential. You have to go sequentially, right? In a sequence, first byte, then second byte, then third byte, and so on. And similarly in stake, you have to also go in the sequence, the very last byte, then the second last, and then the third last, and the fourth last, and so on. So that is the key difference between the stake and the code segment. One of the reason why segmentation is achieved or is performed in the memory attached to microprocessor is because this code segment and stake segment can come to collide with each other, because they are they are sharing the same memory chip. Okay, stake is used to store different information, which includes data and addresses, and both of these storage is just for the temporary purpose. Means stored some certain information is stored in the stake, and then after some time it retrieved back to their normal positions or places. So what are those places we are going to learn in this lecture? Okay, programs and data, whenever we are talking about in code segment, they are stored sequentially, right? And that is the normal address range from 00 hertz to the maximum address, which is 5 times f in hexadecimal. While if we talk about data segment or extra segment, right, so data can be stored anywhere randomly. For example, if it was a data segment, then data can be stored here, then it can be stored here, then it can come back to here, or then it can come back to here. So that means data can be stored anywhere randomly in the memory. You don't have to follow the sequential flow of storage, but in case of code segment and stake segment, you have to follow the sequential flow. While in case of stake, you have to follow the sequential flow, but in opposite direction as compared to the code segment. So if I summarize the whole stuff, stake and code both store information sequentially but in opposite direction, while data segment or extra segment can store information randomly anywhere in the slots of memory. Okay, this is interesting slide which presents a very important fact about stake segment. Okay, let's consider this diagram, which is is on the right side first, and that is actually any memory segment or any memory, but this diagram indicates stake and how they are different to each other. Normal memory is byte-wise, as we have discussed earlier, that when we are dealing with normal memory, they are supposed to be in this fashion, that every slot has got a 1 byte of information, while that is not valid for stake. Stake is rather divided into 2 bytes every address. I mean, right now we are not talking about slots individually, rather addresses. So once, if we are talking about 00, then this 001 address byte is also included. So that's why this address, this single address, is also pointing towards these 2 bytes. Okay, for example, in case of normal memory, this 00 was independent of 01, but here we are talking about 2 bytes of information. That means a word information. So in normal segments, things are like that, 64 kilobytes, because there are 64 kilo locations, and each of those location can store byte of information. That's why we write 64 kilobyte. Right now, in case of stake, they are 32 kilo. I mean, it is the half of this thing. So 32 kilo of word, not the byte, because every address is now referring toward 2 different bytes of information. Because if we are talking about 00, it also includes 01 address in it, so that means it is a word of information, right? 16-bit of information. So rather 64 kilo of byte, now they are 32 kilo of words. That is why stake is 64 kilobyte long. It is similar. I mean, if we talk about the size is of course 64 kilobyte, but it is organized as 32 kilo words. So one can clearly see, if we talk about the size of stake, it is still the same, 64 kilobyte, right? This is the size. But if we talk about the organization of stake, it is organized as 32 kilo words. So that is important fact about stake, which is a bit different from the normal memory segment. Okay, in this slide we are going to learn an interesting fact about stake. Let's say stake is empty, we don't have any information, so the pointer will be on this very starting address or very largest address of stake, because stake is store always information in reverse order, right? So very first information is going to store on the very largest address. So stake is empty and we don't have any information inside this stake. So let's say we bring some information inside stake. So let's say we put a word 1 2 3 4 hacks in stake. So what will happen, since the pointer was pointing to this location, since this location is occupied, the pointer will no more stay here and it will go up, since this location is already used now. But that is not actually the original case in the stake. What happens actually, these 2 locations never used, rather whatever the information we are going to store, it will be stored here, 1 2 3 4 hacks. Earlier pointer was here, but that was also the start of the stake. What happened now, we have stored an information which is 1 2 3 4 hacks here, and pointer is pointing to this location. This is because pointer always points to the very last address which is used. Since this is the last address which is used in the stake, so pointer will point to this location, and we can say that we can see the value of stake pointer is FFC. Look, uh, this is the FFC, the value of offset, and it is also the content of stake pointer. Similarly, let's say we now store another information 2 to CT. Okay, what will happen now? This pointer will no more point to this location, and it will shift to this location, which is the new address of the last address used. So here we learn an important fact that these 2 bytes, let me point, these 2 bytes will never use, and in starting pointer was here, but as long as we start filling some information in the stake, pointer will jump to the location which is the last use. Since 2 to CD is the last information which is used in this stake, so pointer is also pointing to this address, which is FFFA, and pointer is here, the pointer of stake, which is known as stake pointer. Okay, in this slide we are going to introduce some new terms which are very oftenly used in stake. So here we have given with a stake which is filled up to this point, triple F8, and the last content or the last word which is stored in the stake is 3344. That is why this particular address triple F8 is also the content of stake pointer, right? So here we comes to the an important term. Whatever the last information stored inside the stake, or the point up to which we have stored information inside the stake, is known as top of a stake, because this is something up to which you can see the stake is filled and the remaining part of the stake is empty. So that is why it is also considered the top of the stake. So the last word which is used in the stake is also known as top of a stake, and top of a stake's address is, in this particular case, SS colon triple F8, right? Triple F8 is the content of stake pointer, and whatever the segment registers value, so that that thing can be used to calculate its physical address, that we're gonna do in latter part of stake lecture. Now consider these 2 bytes. Let me highlight again these 2 bytes which are never used, but whenever stake is empty, we don't have any information stored inside it, right? So then that particular area is called bottom of a stake, right? Because it is the bottom of the stake at which actually stake starts. Okay, so bottom of stake refers to this value, and in this particular bottom of stake pointer value is always triple F E. Similarly, if we fill this complete stake up to this point, right, we have filled so much data inside this stake, and now stake is full, so it will point to this last address, and that is also known as end of stake. So if stake is full, so what will be the value of stake pointer? That will become 000, because stake pointer is continuously decreasing as we are storing the information. Look, the starting value of stake pointer was triple FE, then it subtracted by 2, it becomes FFC, then subtracted by 2, FFFA, and so if we fill the complete information, so last word which will be stored inside this stake will be SS colon 4 times zeros, and that is also the end of the stake, which will dictate that stake is now full. So these are the terms, 3 important terms: bottom of the stake, the starting address of the stake, top of the stake, the very last used location, and the end of the stake up to which we can actually fill the stake. Okay, in this slide we are going to consider a complete empty stack. Look, in this diagram we see no value is stored in this stack. Furthermore, these last or this starting word of stack or this starting storage place is highlighted because we want to show that this location can never be used. So whatever the information we are going to push inside a stack, that value will be stored here and here and here and so on. Okay, so, uh, this is the starting address. So since stack is empty, that is bottom of the stack as well, and at this point, since we haven't filled any information, this is also the top of a stack. That is the thing that we wanted to discuss, that if your stack is empty, so basically top of stack and bottom stack are same positions, because and right now top of stack is the position which is supposed to be bottom of stack. So if stack is empty, your bottom of stack becomes top of stack. So in this case, the stack pointer value will be FFFE for both of these, bottom of stack and top of stack. Now let's consider we have full the stack and we have filled so much information. Again, if one want to observe, these 2 bytes are again highlighted because we are just interested to show that these two locations will never be used in storage purpose, because whatever the information is going to store inside the stack, that will store at 1 2 3 4 at this state, CCDD at this state, at this address 5544 at this address, and similarly the whole stack is full, and the very last information which was sent into the stack was 3344, and it is stored in the very last address, that is SS:000, and stack pointer value is 00, and that is also considered as end of stack. Here we are here we come to an understanding, since stack is full, so what will be the top of the stack, because it will also be end of stack, because let me use the pointer. Yeah, we can see top of stack and end of stack are same value, because stack is full and top of stack points to the last point which can be used. Okay, so both of these values are equal at this particular case. We have considered empty stack case, and now we are considering full stack case. So in this case we come to know that end of stack and top of stack both are equal, and the value of stack pointer is 000. In this slide we are enlisting all the stuff so far we have learned about stack. So that is also kind of summary slide. The very first point is first word location is never used. That means these 2 bytes are never used, right? That is the very first thing we understand in this lecture. Then logical address of last word stored in stack is basically this thing, stack segment colon SP, or if you are interested to know what is the logical address of stack pointer or stack value at any instant, so that can be given by two registers. One is stack segment register and other is stack pointer. The third point, which is interesting one, the bottom of stack, of stack is always constant, which is this point. Let me use this. Yeah, FFFFE, and it will never be used as explained in the first point. So bottom of stack is always FFFE, and similarly end of stack will always be 000. So stack pointer value will always 0000 in hex, and top of stack. Before we go to top of stack, we know bottom of stack and end of stack are kind of constant addresses, This is always bottom of stack and it will never change. Similarly, this is end of stack and it will never change, but top of stack always varies. For example, in case of empty, top of stack will be here. As we start filling information, top of stack will jump slowly and gradually. And if stack is empty, sorry, if stack is full, so its top of stack will be end of stack. So that is what written here. Stack pointer is always variable in case of top of stack, while in case of bottom of stack and end of stack, stack pointer value remains constant. But in case of top of stack, the stack pointer is a variable. It varies from bottom of stack to end of stack. In case of empty stack, it is equal to bottom of stack. In case of full stack, it is equal to end of stack. So these are important points that we learned throughout this lecture. Okay, thank you so much for listening, and that's the end of the lecture. I hope I have cleared the very basic concepts about the stake, and if you have got any questions about these basic terms which we learned today about stake, please note them down, and we are going to deal with those queries in the online session. Thank you.